In this lesson, we will cover the REST API convention, which provides a set of guiding principles for transmitting data between clients and services on the World Wide Web. First off, what do the terms REST and API mean? REST is short for Representational State Transfer, and API is short for Application Programming Interface. In computing, an interface describes how a piece of software can be used without revealing the underlying implementation of the software. Representational state basically means data at a given point in time. Putting these together, we can glean that a REST API provides a way to transfer data between web components without the client having to understand any of the mechanics of the underlying database layer. To make this clear, we will look at some examples. But before we do that, we need a format to represent the data we are going to transfer. In this course, we are going to use a data format called JSON, which stands for JavaScript Object Notation. Despite the name, it's completely language agnostic and follows similar patterns found in a variety of programming languages. For example, the syntax may remind you of Python's dictionaries and lists. JSON is built on two data structures, objects which are collections of key-value pairs, like a Python dictionary, and arrays which are ordered collections of values, like a Python list. The keys of an object must be of type string, but any other values can be of one of the following types: string, number, object, array, boolean, or null. In this case, a number includes both integers and floats. For example, a university course might be represented in JSON in this way. You can see the similarity to a Python dictionary. The data for the course is surrounded by an outer set of curly braces. Then inside these braces we have key-value pairs, such as the key department code, which contains the value math. Now let's imagine that a client makes a GET request to an API server, hosted at the fake address https://newcamp.edu/get-data. The client then receives this JSON response from the server. However, the REST API conventions also call for consistent URL path structures. Get-data is quite vague and doesn't provide any context for the intent of the request. Let's see if we can do better. URLs lacking structure are brittle and increase the cognitive load of developers as well as the complexity of the programs. To solve these problems, the REST API conventions call for URLs to organize data resources into named collections and identifiers. An appropriate endpoint for our example would instead be /departments/math/courses/101, where departments and courses are names of collections. To target a specific resource within a collection, a unique ID may follow the collection name. In this case, math identifies a particular department, and 101 identifies a particular course. This is now an endpoint that can be parameterized into departments, department code, courses, and course number. Now we know where we are likely to find data for Bio 210, Physics 140, Chem 210, and so on and so forth. Path segments that are designed to hold different values in this way are known as route parameters. What makes this convention even more compelling is the way we can walk backwards down a path and still understand the intent of each request. For example, get/departments/math/courses should respond with a list of courses in the math department. Get/departments/math should respond with information about the math department itself. And finally, get/departments should respond with a list of departments. There are similar path conventions for working with other request methods like post or patch, but those will be covered in a future lesson. In the meantime, consider what it means for clients and servers to agree on a set of conventions. Using standards like JSON, REST, and HTTP allow distinct components in a network to speak the same language, as it were. without the need for a layer to perform translations between different formats. This is the concept known as interoperability. The REST specification also includes guiding principles about more advanced topics like caching and system architectures. We won't cover those, but we will provide some additional resources in the video notes for those who are interested.